last speaker is Michael. He grew up in a small family farm in Switzerland and then migrated to Brazil for work and life. And parentheses, I'm jealous. He's a trained engineer and data scientist and received his MicroMasters from MIT. He's a part of MIT Alumni for Climate Action, and a co-founder of an NFP on digital inclusion for farmers. So also serves as an independent data scientist and AI developer with focus on climate and agriculture. He's also an investor and co-developer in various initiatives. So I pass it on to Michael. Please take it on from here.
Yes, thank you very much. I promise I'll make it quick. I won't go into technical details in this 10 minutes or so. I just will present you an open source project, ODAPES. It stands actually for Open Digital Agronomy Platform for Efficiency and Sustainability. That's where the name comes from. And the idea is to bring the open source idea, which we see a lot in software development, a little bit further down into digital agriculture or agronomy. Sorry, can you go ahead? Yes. First, why we are doing that? If we look at how we manage our lands and what is the impact on climate, we can say today that we have a fairly balanced situation. Our lands absorb about 13 gigatons of CO2 every year, and they also emit about the same amount. It depends, of course, a lot how we measure it, but you can say it's almost balanced out. Please, ahead with the animation. Now we have the situation that in the next 30 years, we have to grow about 50% more food, 56% is the FAO estimation. So what will happen next, please? If we go on with business as usual, this is what will happen. So instead of having a balanced situation, we will, our forests, our lands will sequester almost the same amount, maybe a little bit more, maybe a little bit less, but they will emit a lot because what we are adding are probably mostly meat eaters, right? People as incomes grow, they want to consume more meat. We will probably deforest a big part of our native forests, which is a very negative thing, and this all emits greenhouse gases, and so that's a situation we don't want to have. Next, please. Rather, we want to have that because the nice thing is our lands, our forests, our ecosystems, they also have the potential to absorb much more CO2 than they do actually today. So that would mean then in that situation, we would even increase the absorption rate of CO2 of our lands, and we will diminish their emissions. So that means we have a carbon sink. That's a big deal today because we can probably farmers can then sell carbon certificates on the market. Well, if we look at that, mostly we farm very inefficient today, and mostly this is my claim, my personal claim. I don't have a hard proof for that, but I say the biggest part is an information problem. We don't know when, what, how to apply, how much fertilizer, when to spray, and so on. And that's where we can help with AI. So please go ahead. How are we going to do that? Well, to understand how we're going to do that, let's first look how we probably won't do it. I have here two examples of two Agritech startups, both modeling using AI to make crop models. The first one, Booster Agro, is a small Argentinian startup. They're doing mostly weather and crop weather forecasts. They're having a profit of about $200,000, very small thing, and they manage 17 million hectares. That means 1 to 5 cents per hectare. That's very little money. So if you extrapolate this to the whole market of, in my case, Brazil, which is one of the biggest countries in terms of farming, you have a market size which is below 10 million. So that's not worth to really invest. At the other extreme, We have a Canadian company, which is one of the best or one of the leading smart farming companies, Farmers Edge. Probably many of you know them. It's a very good company. They have excellent scientists, excellent data scientists. However, if you look at their results, after 15 years of life, so after 15 years of improving their models, developing their platform and so on, they still have a negative cash flow of $96 million. I don't know if it's Canadian dollar or US dollar. I think it's Canadian. But anyway, so did a successful IPO, 170 million. I just don't know how long it lasts. That's probably the way how we want to do it. Next, please. Next, please. Yes. So what is the problem in our now to add in our, if you look at the business model of all these companies, you always see more or less the same picture. You have some sort of platform, mostly AI-driven platform, and this platform centralizes almost anything, right? From crop yield forecast to weather forecast to farm equipment management to the whole soil and agronomic stuff, and so on. So and then you have the technical problem, which you see here. By the way, this Excel spreadsheet is on purpose walking out of the screen because it's about 1 meter longer, actually. This is how a typical data set looks like, which clients sent us. You have about 30 to 50 variables which can impact your crop, and you have maybe 10 years of data, right? You don't need to be data scientists to understand that this is very hard, or this is not even possible to get any information out of that, right? So that's the big challenge. That's why probably many of these ideas that you centralize anything in one super intelligent platform and manage the whole agriculture of this world almost from one platform doesn't really work. Okay, next please. What is the alternative? Our approach is actually, we won't take the human being out of the picture. Who is the human being? Is this guy here on the right? Okay, the left is probably the farmer, the right is the consultant. We have about 20,000 cooperatives, agronomists, and university scientists, agronomists, all in only this country here. Right? This is a massive amount of people. They earn their money. They are professionals. They understand the farming. They know. They understand the biology and the weather in that particular place. They also know the social conditions. One little example: we have a lot of customers which are not able to read a simple chart. Okay, simple XY chart. They can't understand what they should do, and you have to think about that. If you want to be successful, you have to think about that. It doesn't help if you have the best AI model if your clients can't apply or use it. Okay. Another thing, you remember the 1 to 5 cents per hectare, which some startups make. A good consultant down here in Brazil or in Chile, they are doing $15 per hectare on the year. That's much more. If we calculate, if you do the math, $15 per hectare, we have 70 million hectares. That's a good market size, right? And last but not least, for the diversity, for the biology and the climate, diversity is much better. Nature is by definition diverse, complex, and not organized. So if you try to do everything in the same way, everything standardized, and see the field as kind of the extension of your working bench, you're working against nature. And that's exactly what we're doing in farming, and that's why it's going the wrong way with our soils and our lands. Okay, so that's how we want to do it. We want to empower these guys and give them access to AI and to digitalization. Okay, next please, last one. So you will see the platform, how it is. It's an open source platform. Just watch it here on the right while I'm speaking. It's a free digital agronomy infrastructure. It's based on open source R packages. It's basically just any module the platform has. It's what you see is like a package. You just have 2 lines of code, you import it, and then you feed it to data, and you have your platform. Of course, we also have some commercial flavor in that. That means we have some API services where we use AI algorithms. It's mostly agronomic algorithms we use, where we use AI or machine learning to take better to calibrate. For example, we do a lot of mapping, we do a lot of interpolation, cross-verification. What we're doing, for example, is management zone planning, depending on the equipment, depending on the different information the farmer has, how should he plan his zones, also optimization of dosages of fertilizer, of pesticide, instead of applying just uniform quantities of this fertilizer over the field, apply this to some variables. And what is very interesting, which I'm always surprised that I don't see this more often, is we use a lot of Bayesian statistics, Bayesian models. Why? Remember, we have very few data, right? So on the other hand, we always have an agronomist, which has some idea. He has some perspective. What we often do is we model well, maybe in the end, making some promotion for Brazil, because our Canadian friend also made some for Canada. I always say, if you wanna solve the climate change, we have to protect the Amazon forest, right? Brazil is #1 today in farming. We just overtook the US in soya production, and it's continued to grow. So we will feed anyway this 50+% of food increase. If we don't find ways to grow that food without compromising the Amazon forest, we are just lost. So come down here, help us. We need good AI engineers, machine learning engineers. We have plenty of opportunities, plenty of investments, and it's a nice and warm climate here, by the way. Thank you very much.
Thank you so much, Michael.